Hey guys, lesson 5 is still talking about volume because that's what this unit's focusing on, but now we've switched shapes and we're talking about the volume of a cone. So it's really similar to the pyramid, but the base isn't going to change between an octagon to a square to a whatever. It'll always be a circle. So you technically can still think of 1/3 area of the base times the height. We're just going to get more specific because this base will always be a circle. So the formula is going to be 1/3, and then the formula for the area of a circle is pi r squared. We'll multiply that by the height. That's the formula for cones. And as always, if you have a cone that's like crooked, essentially, then we're going to just call it an oblique shape. So you just call it a different name, and then you move on with your life and use the same formula. So when I say pi r squared, I am referring to the radius. So we all have to be careful about the diameter. When I say height, I do mean from this apex straight to that center. Do not ever use this one that's labeled as S. I don't think it'll show up in any of these pictures, but just to be sure. So we've got some cones, so we're going to find the volume of it. So 1/3 pi r squared times h. One of the annoying things about this section is, yes, we still have that fraction, but we've thrown pi back in, so now we have to care about in terms of pi again. So looking at this problem, I need my radius. So I need the distance from the center of the circle straight to the edge, which is given to us. We don't have to do anything. So I'm going to say we'll take 1/3, we'll take pi, but I will have to take 4 and square it. And then I need the height, the distance from the apex, the pointy part, straight down to the center. So I'm still going to deal with this in chunks because I think people are more successful that way. I'm going to ignore the 1/3, I'm going to ignore the pi. In my calculator, I'm going to do 4 squared times 3, which is 48. Then I'm going to divide 48 by 3, because that's, remember when we said 1/3 times 48, you can do 1/3 times 48. Or you could just take 48 divided by 3. That's how I'm getting 16. But I still have this pi. You cannot just drop pi. There's a circle in the shape. Pi has to be involved. So that is our answer in terms of pi. So I have it rounded. It's exact. And then if I take 16 times pi, which remember I showed you before where the pi button is, I'm seeing 50.2. So it's about 50 cubic centimeters. So it's kind of just throwing together a bunch of things. We've already dealt with in terms of pi when we did cylinders. We already dealt with 1/3 when we did pyramids. It's now just do it all in one problem. So let's try another one. It's still a cone. It's just like a cone that fell over. Oops. 1/3, 1/3 pi r squared times h. So I need to find the radius, which is the distance from the center to the edge, which is not what we're told. This, just labeled as 12 kilometers. That's the diameter. I don't want that part of it. I'm going to unhighlight it. This is the diameter. I only want the part that goes from the edge and then stops halfway, which means I want half of 12. That's what we will use as our radius. So that's definitely a pitfall. Don't just get in the habit of just throwing in whatever numbers you see. Pay attention. Is this actually the radius? The height is the distance from the apex, the pointy part, straight to the middle of the circle. So we do get to use that 12. And now I'm going to pick up my calculator. I'm going to ignore 1/3 times pi. I'm going to take 6 squared times 12. And I get 432. 1/3 of 432 divided by 3 gets me 144. And since there's a pi there, then I have my in terms of pi answer. 144 pi cubic kilometers. Then I go back to my calculator and multiply 144 by pi, the button, and that's how I get 452 when I round it to the nearest whole number, because there's a 3 after it. So just kind of combining a bunch of things all together.